Hello guys, welcome to Self Help Maths Academy. Today we're going to discuss about the null space. Okay, so what is the null space? First let us try to understand. The null space of a matrix A, we'll define this. The null space of a matrix, we have to define it for any matrix of order m cross n. A null space of a matrix m cross n of A. Okay, we also written this null space as, say, null A. This is it is the set of all solutions to the homogeneous equation Ax equal to 0. Okay, so in short, the null A is x such that x is in Rn and Ax equal to 0. So let us try to understand the meaning of this. So here basically we are saying that the null space of a matrix m cross n. So here the matrix order is, it's not necessarily to be a square matrix, it is any matrix of order m cross n. It is the set of all solutions. It is the set of all solutions to the homogeneous equation Ax equal to 0. So where your matrix A is a m cross n matrix, we should find out the set of all the vectors X such that Ax is equal to 0. So this particular homogeneous equation yields to many set of solutions. So we will take the collection of all those vectors X, and these vectors are in Rn. If A is a m cross n matrix, then your X is of order, X is in Rn. I mean, for example, if it is a 2 cross 3 matrix, then X is in R3. If it is a 3 cross 4 matrix, then your X is in R4, and so on, like that. So we are taking the collection of all such X's, so, that X's should be in such a way that the A into X should be equal to 0. So then we call that the matrix A. I mean then we call that the null space of a matrix A will be this, the set of all solutions which obeys this condition. Okay, so now let us see with the help of example, okay, that how do we approach to this. Suppose we have a matrix A. Say let A is given by, say, 1 minus 3 minus 2 minus 5 9 1, and let U is equal to some 5 3 minus 2. The question is determine if U is belongs to the null space of A. So whether this U is belongs to this null space of A, that's what we have to find out. So to understand or to find that, to test the satisfaction, what we have to do, we have to just check if I get the product A into U as 0 or not. If A into U is equal to 0, then U is in null A. If it is non-zero, then it is not in null A. It's a simple computation. So just we will now find out A into U. So we will get 1 times of 5, that is 5, minus 3 times of 3, minus 9, minus 2 times of minus 2, which is plus 4, minus 5 times of 5, minus 25, then 27, then minus 2. So clearly this gives us 0, 0 vector. Okay, so thus we have got A into U is equal to 0. So therefore U is in null A. Okay, so the term space is a null space. Usually the term null space is very appropriate because the null space of a matrix space is what? A null space of a matrix is a vector space. Okay, so therefore calling null A as a null space is very appropriate. Okay, so now let's see one of the property of the null space. It says that the null space of an m cross n matrix A is a subspace of Rn. Okay, so null space, if you consider all the, the the null space of a m cross n matrix, so whatever you are taking the null spaces as we defined, we have seen that it is that x which is satisfying a into x equal to 0, where a is any m cross n matrix. So such x's, so the collection of all the possible x's, like the null space of an m cross n matrix A, it is a subspace of Rn. So it will be always a subspace of Rn. So this is very important and interesting property. It is equivalently what we are saying. We are saying that set of all the solutions to a system of equation Ax equal to 0. The set of all the solution to the system of equation Ax equal to 0, where we have m homogeneous linear equations and n unknowns. It will be a subspace of Rn. So that's the meaning. Okay. So it's very important and considerable fact. Okay. So now let's see. Let me understand with one example. So let H be the set of all vectors in R4 whose coordinates are A, B, C, D. Satisfy the equation A minus 2B plus 5C equal to D. C minus A equal to B. Okay, so this is given. Show that H is a subspace of R4. So let us show that this H is a subspace of R4. So now what we will do, we'll try to rearrange this equation. So we'll write this as, say, A minus 2B plus 5C minus D equal to 0. I'm just writing it as a with the rearrangement. Similarly, we have here minus A minus B plus C equal to 0. Okay, so now if you carefully observe, let me write here from this one. I will try to write my A. I'll take that A on the other hand. This will become A equal to minus B plus C. So this, let me take this as star and let me take this as, say, 1. I substitute the value of A as minus B plus C in this one equation, equation 1. So this will be A minus 2, A value is minus B plus C minus 2B plus 5C minus D equal to 0. Okay. So now minus B minus 2B is minus 3B plus 5 plus this will be plus 6C equal to, I will write it in terms of D. Now if you observe carefully, your A and let me take this as double star. Your A is in terms of B and C and your D is in terms of B and C. Okay. So if I want to write it as a solution, then as a general solution mode, so we can write this as, if you see, it is A, B, C, D. Okay. So A is minus B plus C. B is B and C is C. D is minus 3B plus 6C, which is equal to B into. So here it is negative 1, 1, 0, minus 3 and plus C into 1, 0, 1, 6. Okay. All right. So now if you see this particular equation, we have written A, B, C, D in terms of B into something and C into something. Means B and C are the free variables. So they are like, free to choose any values. All right. So if you see, now these are the two vectors. These are the two vectors which are in null space, because by putting any value for B and C, okay, by putting B and C any values, okay, then it will lead us to all the values of A, B, C, D. Okay, so then if you observe carefully, by substituting those values we will get a null space. Okay, so therefore what we can say, that this by the above theorem, like the above property which we discussed, the null space of a m cross n matrix A, it is a subspace of Rn. So therefore here in this case, these two vectors are in a null space. Okay, so by substituting the b and c value, we'll get infinitely many solutions. So the collection of all those vectors forms the null space. So by this particular property above which we have discussed, it will become a subspace of 1, 2, 3. For there are 4 elements, hence it is a subspace of R4. Okay, so that's why we have to answer this question. Now let me try to understand the spanning set. So here question is, find the spanning set. We have to find the spanning set for the null space of a matrix. For the null space of a matrix, say A, that is -3, 6, -1, 1, -7, 1, -2, 2, 3, -1, 2, -4, 5, 8, -4. Okay, so they ask us to find out the spanning set of the spanning set for the null space of this matrix. Okay, so when they ask us to find out a spanning set, the first step is to find out a general solution of ax equal to 0 in terms of the free variable. Okay, so what then we have to do? We have to row reduce the augmented matrix. We will take Ax equal to 0. Then we will row reduce the augmented matrix A0 in a echelon form, reduced echelon form, in order to write the basic variables in terms of the free variables. Okay, so that is the step. So here, as you know that I'm going to use this matrix now. I have to find out some x. When I have to multiply this with some x, this should give me the value equal to 0. That is the whole idea. So now let's start with a augment with 0. So that's what we will get. So here this is a given matrix, and I will write this as -7, 1, -2, 2, 3, -1, 2, -4, 5, 8, -4. This we are augmenting with 0. Okay, now what we'll do, we'll just try to see. It is easy if I just interchange R1 and R2 so that I'll get the 1 here. So I will do the stepping that I'll interchange R1 and R2. Okay, so what we get? We get here 1, -2, 2, 3, -1, 0, 0, 0, -3, 6, -1, 1, -7. So this is 2, -4, 5, 8, -4. Okay, now if you observe here, we have -3 and here we have 2. So let us make them 0 by using R1. So R2 changes to R2 plus 3 times of R1, and R3 changes to R3 minus 2 times of R1. Okay, so by doing this, we will getting 1, -2, 2, 3, -1. So this is -3 plus 3, which is equal to 0. Then -6 plus 6, it will be 0. -1 plus 3, so that will be 5. And then 1 plus 9, that is 10. -7 minus 3, that is 10. That is -10 here, and it is 0 here. So 2 minus, here simply 2 minus 2, which is 0. -4 plus 4, which is 0. Then 5 minus 4, which is 1. Then 2 minus 4, this is -2 here, which is 0. Okay, so this is the next one. All right, now let me, here you have got 5, 10, -10. So let me take R2 changes to 1 by 5 times of R2. I will just take that 5 out here. So the simple row operations which we have used so far, guys, it's the same thing. We should know first we will use R1 and then we will use R2 in order to change. Then we will be coming up with R3 like that. Okay, so the same steps you should use. It is 1, 2, -2, 0, 0, 0, 1, 2, -2, 0. Okay, so with the help of R2 now, I'm using R2 in order to make this element 0. So therefore R3 changes to R3 minus R2. Simple, that we will do. So here we get, so it is 1, -2, 2, 3, minus 1, 0. So 0, 0, 1, 2, minus 2, as we are not doing anything here. So this will be simply 0, 0, 0. Okay. So if you observe, if you remember the property, if after doing the row reduced echelon form, if you get any one of the row which contains 0, 0, zeros, then it has a free variables. So free variables leads to many solutions. So let us see which are the free variables in fact. So here, if you observe carefully, so this is the pivot position. So this has to be a basic variable. The next pivot position should be here, but since it is 0, I should shift it to here. This is the next pivot position. So here we have got only two pivot positions, as you see. So this is with respect to x1. This is with respect to x3. So x1 and x3 are the basic variables. Remaining x2, x4, x5 all will become a free variable. So we have got here three free variables. So let us write them write this particular thing in terms of a solution. So once we write it as a solution, here we will get, let me write this as an equation first. So this way, this one is like x1 minus 2x2, 2x3, 3x4 minus x5 equal to 0, and here it is x3 plus 2x4 minus 2x5 equal to 0. Okay. So therefore, let me write this as in terms of x1. x1 is 2x2 minus 2x3, yeah, minus 3x4 and plus x5. And from here, from the second equation, if you observe, your x3 is minus 2x4 plus 2x5, right? So I'm going to substitute this value here. So therefore, our x1 will be 2x2 minus 2 into minus 2x4 minus x plus x5. Okay, so this is equal to 2x2 plus 4x4 minus 4x5 minus 3x4 plus x5. So this will be like 2x2 x4 it is plus x4 and minus x to the power minus x 3x5. Okay, so this is what we have got now. Now if you see, we will write it as a general solution. If I write this as x equal to, say, x1, x2, x3, x4, x5, this is equal to 2x2, 3x5. x2 is free, so let us write it as x2. x3 is minus 2x4 plus 2x5. x4 is x4, x5 is x5. Okay, so now this is equal to, now let me write this as in terms of x2 and x3, x4, x5. So this x2 into 2, 1, 0, 0, 0. Okay. Then plus x4 into, this is 1, 0, minus 2, 1, 0. And x5 into, plus x5 into, here we got minus 3, 0, 2, 0, 1. So here if you observe, we have got x4 into this vector, x2 into this vector, x4 into this vector, and x5 into this vector. So by changing x2, x4, x5 value, we'll get infinitely many solutions, right? So now the collection of these three vectors, if you see one particular set, okay, 2, 1, 0, 0, 0, and if you take 1, 0, minus 2, 1, 0, and minus 3, 0, 2, 0, 1. So this is one set of spanning vectors which are in a null A. Likewise, by just substituting a value of x2, x4, x5 differently, you'll be getting all the possible different collections. Okay, so this is these are the sets. Like here you can see that this you write it as x2 into u plus x4 into v plus x5 into w. So these are u, v, w are the vectors which are in span A. Okay. So every linear combination of u, v, w is an element of null A. So thus u, v, w is a spanning set of null A. Alright. So therefore what is important here is the spanning set produced by the method above which we have discussed now is automatically linearly independent. Means these three vectors, they are linearly independent because these are related to the free variables. When they are related to free variables, automatically these are not scalar multiple of each other. So therefore this x2 into u plus x4 into v plus x5 into w can be 0 only if x2, x4, x5 are 0. So that is the only solution, right? Then we say that this u, v, w are linearly independent. So when null A contains non-zero vectors, then the number of vectors in the spanning set of null A equals the number of free variables. All right. If it contains a non-zero vectors, then the very important thing is, so the number of vectors in the spanning set here, the number of vectors are 3. These are the spanning sets in null A. This is equal to the number of free variables. If you see how many number of free variables we have, that many number of spanning vectors we will be having. Okay, so that is very important. All right. So this is one of the basic understanding of null A. So likewise, you can solve the examples with the different matrices by taking the different matrices and taking the augmented taking the homogeneous equation with that particular matrix and take augmented matrix as like this, A with 0, and then do a row operations and find the free variables as we did, and then write the basic variables in terms of the free variables and then find the corresponding vectors. Those vectors will be the spanning set vectors. All right. So this is all in this video, guys. Maybe in the next video we will discuss about the call space or the column space. Till then, take care, guys. And if you have any questions, any comments, any questions, or for example, let me give you one example to solve for yourself. So maybe you can comment the solution or the spanning sets in the comments. Okay, so let me give you the matrix as A equal to, say, 2 4 minus 2 1 minus 2 minus 5 7 3 3 7 minus 8 6. So for this matrix, 3 cross 4 matrix, please find out the null space and give me the answers in the comment. I think that you will do, guys. So till then, take care. Bye bye.